Cool.
Good morning, everyone, or afternoon or evening, depending on where it is you are. Today, on this episode of API Review, we're looking at the API involved in doing source generation for system text JSON. So, Laomi, that's you.
Yep. So there are various scenarios that make us interested in generating source code for system text JSON. We have a couple of these as top-level user stories for .NET 6.0 that we've shared. Developers apps using system text JSON should start up and run faster. Is a scenario, as well as developers being able to trim their apps that use system text JSON safely and reduce the size of their apps. So we expand this into these goals, which are to reduce startup time for apps that use system text JSON, reduce private byte usage for apps that use system text JSON, improve serialization throughput in apps that use system text JSON, reduce the size of the apps, and get rid of all the linker warnings caused by apps using system text JSON. Couple design constraints. We want to avoid like magic that involves any sort of auto-registration or integration of generated source code. For example, with reflection. Some serializers like XML do such things to integrate the generated source code into the application. And as a result of the Roslyn feature for C# source generation, we can only generate into users assembly. So any ideas around sidecar assemblies or a shared assembly for multiple assemblies to consume is not in scope for this. And also, across different assemblies, at the same time can have different like metadata composition. For example, like private internal members in one assembly will not be visible from another. So it gets confusing when you try to share metadata in that way. So just an overview of the approach for source generation. It's primarily metadata based, where we basically move the reflection-based metadata gathering about a type from runtime to compile time. And that's how we're able to achieve most of these goals. So that way, we're not doing runtime reflection to understand the type and know how to access members on it, like constructors, properties, fields, etc. We do that during compile time. We pass the metadata directly as an argument to the serializer method. This way, there's no magic, and it's an explicit like integration into the source code. And it also helps with linker goals, because if we base it on the options, then the serializer doesn't understand the type yet and needs to do reflection. And by passing it directly to the serializer, we're able to trim out code that is not going to be used. And we also provide this proposal includes a fast path serialization logic approach for simple POCOs. Simple POCOs here meaning that they only contain members that can be handled directly by the lower level UTF-8 JSON writer. So ints, date times, GUIDs, etc. And simple JSON serializer options usages. So I'll go into that a little bit more. So at this point, I will share like a small demo to go over like what the change looks like. But before we'll see like the before code, you basically pass an object to the serializer, get a byte array as return, and then you can deserialize it as well. So Visual Studio is fighting me a little bit today, but this code compiles. There's no issue with it. So any squiggly lines are things that were auto-generated. So given a class that you have an int property collection of strings, straightforward. You specify to the generator that you want to generate source code for the type. I have another type here as well. And the generator proceeds to generate information relevant about type. And this is the generated metadata for the type specifically. I'll go into what it looks like. So you, instead of passing options or passing nothing at all, you pass the generated metadata. And similarly on the serialize, you pass the metadata for the type as well. So the return type of this is something called JSON type info of T, where the T matches with the T of the deserialized method. So here you see that you don't need to specify like a generic type argument. Then you perform serialization in essentially the same way. I also show an example of the path, fast path usage. So you see, it's similar to my class. So this is a generator for the point class that I show here. Then we generate a method on that metadata class, which accepts a writer, accepts an object, and accepts serializer options. And we can write directly to the writer. So, and this same method that we generate can be consumed within the serializer itself as a fast path. So it's composable with the rest of this design, but can optionally, or the proposal here is to expose this directly to users to provide that logic. So what is the generated code? We have this top level JSON context class, which contains metadata about the entire assembly, so assembly level attributes. So every metadata class that every type that you specify will be represented here. So this is not handwritten, I'm just cleaning this up. So we have a default property, and what this does is to create an instance of this using default serializer options. Today the default is internal, so we just clone that default. And the reason it is cloned is to maintain a one-to-one pairing between the context class and the JSON serializer options instance, because we don't want a situation where one options instance today contain metadata for a type. So if you provide multiple context classes, then that's not a good model. For instance, if you wanted to say options that get converter, you would only want the option to get the converter from one metadata class. So we clone the options and not keep track and not hold on to the default one, so that we can force a one-to-one pairing, basically. So we use this constructor to do the cloning internally from the JSON serializer context class, which is the base abstract class. Then also we generate this from method where you can specify your own custom options, and we can honor that at runtime. We also clone the options instance, and that is cheap because at this point we're not doing any sort of metadata generation. So your options instance in this case is just a simple POCO that has a bunch of booleans and enums specifying what you want to do. So so that's how you create JSON context instances to use within your application. This is a one-time generation.
Quick question. So is the idea that the from method will eventually do some sort of interning from the serializer options to the to basically make a one-to-one mapping as well, or is this always going to be just a shortcut to call the constructor?
It also does the same clone I described for the default case. So the intention is just to be able to get your own custom options. Those will be cloned, and then we'll maintain the cloned instance as where we will as the options instance that we keep track of internally. And from the other thing to mention is that from this point where you basically instantiate an instance of this, the options are locked, because it makes it easier for the underlying implementation to reason about what metadata is needed and not expect that users will change it. Does that address your question?
Sort of, that's half of it. So basically you're saying, even this one will also just clone the provided options. But my question is more is from always just calling the constructor directly with no, dictionary lookup or anything else? Because then it might be easier to just literally give people the constructor.
Yeah, it's not doing anything else, just cloning the options. So,
Just take all the values like the nullable settings, you know, default settings, that sort of thing, and just copying them over as properties, right?
that's all.
Not copying any caches or underlying dictionaries that we normally would have on the options.
Yeah, it's similar to the copy constructor that we exposed in 5.0. So we also generate this method to get the runtime provided custom converter, because we have to honor it. So we look through and optimize the implementation based on like the number of converters. But for most cases, we only have like a couple, like 3 or 4, something like that. So this is logic that we generate once to fetch the converter. This is I appear to. Okay, I'll circle back to this one here. So we also generate this type info class, which provides so this is at the level where, so when one of these is passed to the serializer, you pass it along with a type, and then the serializer, and this is in cases where you don't know the type up front. So the serializer will call get type info and pass the type, and the context will return the metadata for the type. That's what this bit of code is doing here. Okay. Now this is my class, the same class that we specified here. This is what generally JSON objects look like, the metadata for those. So first, this is the my class that is referenced. So if you do JSON context.default.myClass, we fetch it here. We first do a null check, and then create it if it's not null. Then the first thing we do is we check if it has a custom converter. If it does, then we basically use the metadata representation for a simple, like for a type that has a simple primitive converter, because that's the only like converter module that we expose today. So, but that module is generally geared for things like simple primitives like ints and strings, but anything that has a custom converter is treated in this simple way where you have like just a custom converter. So if it has a custom converter, then we set the metadata accordingly. And then if it doesn't, then we have a different representation where we first new up an object representation for like the POCO and initialize it with relevant information. So one of the things here is a creation object func to say, hey, this is how to new up this object. A serialized object func, which I pointed out earlier to provide a fast path, is null in this case because this POCO doesn't fit our requirements of what a simple POCO is. In this case, you see the array. It's a different question of whether it should, but like as proposed, it does not. And we pass a function that initializes type metadata for the properties of that POCO. So and this way, the serializer can lazily initialize the metadata for a POCO in the case that either no serialized object func is provided, then we new this up lazily, or a func is generated, but the options that are used is not compatible. So meaning that a more complex like option like reference handling is used, then we'll lazily need this up. So just pass this func. And this is supposed to represent the number handling for the type. So that's what POCO looks like. Here you see we're just doing things like setting what the CLR name is, whether it's a property in a field, the declaring type info. And I'll say that this represents metadata for today, like given these options and features that we have. In the future, like we plan to expose new overloads of these methods that represents like a newer metadata representation of the serializers features. So I'll move on to like string array.
So
Sorry, can I ask a question? Oh, go ahead.
Yeah.
If you go back, I have a bit of a high level question. If you go back to the program.cs, so in the case of the fast path approach that you're talking about, it looks like you're requiring the customer to write new code. Was there never a goal of having the existing code base leverage source generators and just become faster? And if not, why not?
So I think the primary reason why we can't have users code unchanged is because that is not compatible with linker trimming. We need to have a way to specify what is needed in a linker-friendly way. So, and it goes back to, I'm not quite sure like other approaches to have users not change their code that doesn't involve some sort of magic like reflection, which at the beginning of this presentation I stated to be like a constraint, that we don't want to magically do anything. We want things to be explicit and clear, like why we generated code. So we specify an attribute for you to say this is the type that you want. And we just want to avoid a world where we're doing like magical things. So XML serialization is the thing where like a code is generated to a different assembly and it's magically added to the application and users don't know anything about it. But that has also led to a lot of like user experience like issues with.
So,
like,
so what I'm hearing is that you want the customer to give intent that they want to opt into source generations, right?
That's one thing.
Assembly level attribute, wouldn't the assembly level attribute already do that?
Yeah,
so
sorry,
why
that's
would you
just.
want
Yeah, that's just one half of my question. The first thing I said was for linker friendliness. That's the primary thing.
But if someone doesn't care about linker friendliness, they just want improved startup time for their server app or whatever, there's no way that just turning on the source generator with their existing code would allow them to just get improved startup time. They have to change their code even for that.
So with the model and the set of goals, like overall, as we have them today, as we have them stated, and with the user scenarios that we established for 6.0, that where you don't change your code and things get faster doesn't align clearly with those set of goals. So I acknowledge there's a scenario for it, but that's not quite the one where we designed for. The idea of users not changing their code at all was talked about as a very like lofty and ideal mode, which we did not pursue due to the overall set of goals that we were designing for. But in the future, like I mean, the question of code, if we assert that is a goal that we should commit to, then we can think about like what does forward compatibility for that sort of mode. But the overall answer to that question is that is not what we're designing for here.
So just to add on to that, and maybe a little background. Today, the serializer, you pass in a type, either serialization or deserialization, and from that type, we look up the quote-unquote metadata for that, the list of properties, etc. And that uses reflection and does IL emit and that sort of thing. And it does it on a per type basis. We don't know what types you want until you call a serialize method. So it just does it kind of, as you need it. And with this model, we do know the types, and we don't want to use reflection. So that means if you call an existing serialize method without changing your code, but you have the code generated mechanism, then what would have to happen is we would say, hey, there's a context class that has an option, or the options class has a context class, and now we have to find the type, the metadata for that type, and that would probably involve populating a dictionary and then getting once and then reading from that dictionary to get the metadata. So it's possible to do that, and you probably get some benefit, but you still do have the dictionary hit. Plus, you probably populate the entire dictionary ahead of time, unlike what we have today where we can do it as needed. So if you have 100 POCLs generated, we would have to probably create a dictionary of 100 items the first time, which kind of goes against some of the startup goals.
So maybe I'm missing something, but why wouldn't you just say, like when you call JSON serializer deserialize of T, why wouldn't you just say, okay, for the T that I'm instantiated for, take the assembly, try to find whether there is a JSON context object that exists in that assembly. If so, map that to this type, and then say, clearly this assembly opted into source generation that you serialize for, and now you just get this JSON context from there. Like there's a one-time hit that you pay for that if somebody doesn't pass in a context object, but like you still get 99% of the benefit of the JSON context without forcing people to pass it all over the place.
Yeah, I guess the direction we went was that one-time hit was part of what we're trying to avoid. Perhaps it's not as large compared to the rest of the reflection, but.
Well, I guess what I'm saying is, like, if that hit is too hard, I think it's okay to say, you know, if you don't want to pay for that hit, pass in JSON context default to the deserialize as an argument. But if you just basically opt into existing code to turn on the generation, it would be nice if you get like most of the benefits of the source generation, right? Without having to change all the code that invokes the serializer.
What you're talking about is using reflection to scan assemblies, right?
Well, you would only scan the one assembly for which you're invoked for, right? Because if you say JSON context of foo, you just look into foo's assembly whether there's a type called JSON context, and if there is, use that one as the context.
You're still proposing scanning assemblies using reflection.
If you don't pass the context, yeah. If you pass the context, you use the one that is being passed.
I mean, where we're trying to go with .NET is to get away from reflection, right? Like with AOT, like all the new platforms we're trying to build for, we're trying to get away from using reflection by design, aren't we?
Well, I mean, like, it depends on how far you want to go, but like, I mean, there's still reflection going on in many areas of .NET, right? Like we use DI, for example, all over the place. And you can imagine that we replace a lot of that with source generation, but eventually, like you get to a point where you have to wire stuff up, right?
DI doesn't use reflection. I mean, it uses reflection emit to generate faster code, yes, but it doesn't use reflection to scan for types.
And there is a middle ground here. I mean, if you note that if you're aware of the context and you're aware of the new programming model, you could create an options that has a context, but still pass in the options, still use all your other code, just add one line of code basically, and then you hit the mode like I mentioned earlier, where we would have to call into the method that Leomi showed that we know about all of the types, and we would have to add them to a dictionary, etc. After that one-time hit, the performance would be, you know, on par with the Sterilizer. And the benefit you would get is you would be avoiding reflection and reflection emit. I mean, and that would be very trivial to implement. If it's not already implemented in the prototype.
So from the API design perspective, to bolster some of Emo's point, I think it makes sense. I'm looking at the goals that you had shared, that we want to minimize reflection usage because we want to improve startup time, improve throughput. But does that mean that we need to have 0 reflection calls? And if so, why do you want to have 0 reflection calls? Meaning, even in the case of like Emo mentioned, if you pass in the context, the user can opt into saying, I don't want reflection. And they have a mechanism to do so. So there's progressive disclosure. But existing code could continue to work, use one reflection call, and get all the startup and other benefits that we propose from this effort. So what's the harm in having that progressive disclosure approach?
The approach we take here, so that can be considered for sure if there's enough like agreement that, you know, we want to provide that sort of auto registration, but the proposal as it is optimized for the most AOT friendly thing, where any reflection that happens isn't as a result of using system text JSON. And that seems to be like the direction that I want to go for the framework as a whole. And I think the user experience is not that much. We've considered, the change, like adding an additional parameter to, wherever you use the serializer. We've considered like an analyzer that would do this for you. where like we see you using the generator, and then we can change all your code for you because we know what the new code is supposed to look like. I think
so this reminds me a little bit of the saying that make simple things easy and difficult things possible. To me, allowing AOT reflection-free scenario is possible already. I think the feedback is make the simple things simple. The other thing I want to mention is that the regular usage versus fast path usage, can we make that decision opaque to the customer so that we just decide what the fast path is versus regular usage is, rather than forcing the customer to change their code base depending?
Yeah, we do in a sense. Like to get the fast path, it's not as fast. You just pass it to the serializer directly. So just like this, and the serializer knows that it can call this method. This is just in the case where, and this is optional in my view. I mean, it provides the very best performance, right? Because you don't have a little overhead that's associated with going through the serializer. But yeah, the serializer, this is composable where the serializer knows that if you pass just this, the serializer knows it can call this method. So this is optional just to, because the serializer right now uses a pooled binary buffer, which has like some overhead on first use as versus like memory stream. So in the case where you know specifically what to do, I mean, there are various things you can do about that, like say provide a method to not use a pooled buffer and things like that. But ultimately, this is just here as a convenience. If you like if you've read our documentation, know what you want to do, and you know you want the best performance, then you can call this directly. But it's up to API review to say whether or not we should.
Just to clarify, line 21 will figure out if it can go down the fast path and do it on behalf of the customer.
That's correct.
Okay. Do you know what the difference is? Power difference between maybe you'll show it later, but 21 and 30.
Yeah. For on startup, there's no difference. There's effectively no difference, but with throughput, there starts to be a difference. I'll show those numbers later. Yeah.
Okay.
I have another semi-related question. We have an issue where if you don't pass in an options bag, it ends up creating a new one for you, and then today it ends up redoing all of the reflection and stuff, right? So if you throw away the options every time, performance is really bad. Is that true, Steve?
Creating a new options instance, yeah, super expensive because the caches have to get built up. We do have a default one that's private and hidden and immutable. So if you don't pass one in, we always use that.
So for that default one, I guess I'm not understanding what you were saying earlier. If we were spitting out the implementations for all the reflection-based code generation for all these types that are very likely to be used because we're source generating for them, what's the significant downside to adding those, making the call to just add those additional ones into that default bag?
There could be a lot of them, and makes it'll just a little harder to be able to get rid of those references if we don't need them anymore by adding them to the dictionary.
You're saying I have a type in my assembly that I've asked to make serializable, but we want it to be trimmed away if it's not used?
Yes, it's possible.
Stephen, is your question related to this or in general? Because I'm not.
It's related to this. It's related to how to Austin's point about making the simple things simple. Like, what are the minimal changes I could make to my code to get some benefit? And then what are the additional changes I could make to get more benefit? And what are the additional changes I can make to make more benefit? And if I can add a line somewhere in my app that is assembly JSON serializer type, and what that means is spit out all of the reflection code ahead of time as source generated stuff and add it into the default options, then I don't have to change anything else in my app. But if I end up serializing, deserializing, or when I end up serializing, deserializing that type, I don't have to do the reflection and reflection emit for it. It seems like, isn't that, and I think what you're saying, that the overhead there is the cost of the additional dictionary.add and then a few more objects in the dictionary. Is that right?
I mean, you would also end up with a linker cost, Steve, if you had a client library for some JSON-based service and it can do 700 things, and you called one from your program, you're going to get all 700 because they were statically added to the lookup table in DLL main or whatever.
Yeah, I guess I'm wondering how common that is. But for me to have types that I declare as being serializable and then I actually don't want them.
In the case of something like a serial or a client library that gets linked into something, that actually seems like it would be common, especially in the future.
Or multi-tenant, like host with many plugins. System text JSON is going to be used everywhere. So when you start saying, these components which are doing isolated source generation contribute their results to some static shared state for the entire app domain, that can get a little iffy. What if one guy decided? I'm not sure how much applied a converter for a type that he had that was shared by another person who didn't want that converter. I'm not sure how our system would play well with that, but it's possible there's even collisions, right?
Yeah. In many cases, like users have custom options, and it's not clear what the solution would be to accommodate like caching the metadata for those. Like almost nobody that uses system text JSON like at a higher level at like ASP.NET doesn't customize the options. So I think unless you're doing like some crazy console app or microservice type thing, like that's the only scenario where that would be like useful. Well, not useful, but where that we can accommodate.
I mean, nothing stops us from adding like options.register, metadata or something like that you can, add your own metadata ahead of time, like once when you're initializing the options, and then, just go with that and then pass in the options and we do the dictionary lookup like we do today. So, I mean, we could do that, but if you use this new programming model, you're passing in the metadata and you don't have to register it and you don't have to look it up.
But you do need to specify it everywhere you want the benefits of it.
Yes. And if you look at the programming model though, like Naomi said, you typically are passing in the options already today. Probably, 75%, I'm making up a number, but some high percentage over 50 probably are creating a custom option. So this basically replaces the options instance that you pass in to serialize and deserialize with the particular metadata for a class, and then that has a reference to the options. So you basically substitute one parameter for another. So from just looking at it from that viewpoint, you're still passing in something.
I buy, but then the problem is it's error prone, right? Because it will work at runtime. It will just fall back to reflection and reflection emit, right?
That's the problem with linking, right? Is if you have that fallback, you can never link out that fallback, right? If all your places are actually going to use the source generated code, the linker can't get rid of the reflection emit code because there's some path that might take it.
But you get the warning when you called the serialize overload that does reflection.
No, I mean, in the proposed, not in the alternate design that we're discussing, right? There can be no warning. Like you can't mark one of these APIs as this one's not safe and this one is safe because it's the same API.
Well, no, that's not what we were proposing. What we were proposing is saying there's two overloads, one that takes the context and one that doesn't, which is the existing one. And the existing one would just try to find the context. So if you don't want this, you just bypass that call. You just directly pass in the context yourself.
We have a feature to replace the default options, like a feature request. So if we were to go down that route, it's possible that the user can specify one default once, and then we can maybe one time associate that options instance with the generated context, and maybe that will work. So we can circle back. So if you don't change your code, maybe you have to do something to register your generated context with the default options that you set, and that way you don't have to pass it around everywhere. I think that might.
And if if you care about trimming, that means that basically, if you don't want to change your code, if you want to keep calling the deserialize without the context, that means that you're going to get a warning in all of those places. Because as Eric said, like there's no way for us to figure out, but you are setting a context. So that means that you're not going to take the unsafe path. There's no way. So the only way of getting a no warning scenario would be if you call the overload that takes in the context.
Sorry, the overload doesn't exist today, right? That takes the context, or it does?
It's proposed.
It doesn't. It only exists.
So existing code today, if I turn on the linker, I'm going to get a ton of warnings.
That's correct.
System text JSON isn't annotated yet, right, Eric? Is that right?
Correct. Today, you call into system text JSON, you get 50 warnings.
Sorry. Right. Today, when I say today, I mean when .NET 6 ships, and I recompile my app.
Yeah, you will
I'm going to get a ton of warnings.
You're going to get one. You're going to get one for every place you call JSON serialize or deserialize and serialize. The existing API that's in .NET 5.
But to be clear, I only get the warnings when I say link, right? But if linking isn't enabled, I don't get warnings, right?
Right. As soon as you publish trim. So as soon as you use it in Blazor or any sort of MAUI app or iOS or Android.
But that's the default publish behavior for all of those, right?
Yeah.
Correct. Yep.
Yeah. So if for a convenience feature, it seems like that would not be compatible with the linker, but at least you get the other benefits like startup. So
the other.
Well, I guess I'm less concerned I'm concerned in general about the default experience of someone just creates a new app and they copy and paste what they're, the source that people have been using with system text JSON for several releases now, and all of a sudden they get a ton of warnings.
Yep. Same thing for XML serializer. Same thing for data contract serializer. Like none of that stuff.
Yeah, we're just not pushing those two. We are pushing STJ.
Right, and we're making a source generator for system text JSON,
which requires changes to your code.
Right. I mean, logically, like, how are we gonna want to do this for all the other places, right? Like regex, when you want to opt in. Do you know what I mean? Like we're kind of setting
for regex you don't get warnings when you use regex. Like the linker's not going to give you warnings about it. You can opt into using the source generator. You write, an additional 2 or 3 lines of code, and then you're using the source generator. But you don't get warnings.
Stop, but stop. You just had to change your code, right?
Not to avoid warnings. I didn't get any warnings if I didn't change my code.
Well, to opt into the new source gen behavior. This hypothetical one that we.
But forget source generator. You're telling me that forget the source generator entirely. That when I build my existing app on .NET 6, my existing Blazor app on .NET 6, I'm going to get a whole bunch of new warnings.
Wasn't that the exact same thing that happened with nullability, though? Like,
I have to turn on nullability.
Right, but I mean that's the problem is it's a reflection-based thing, so all the reflection metadata needs to be there, so that you get all the hey, I needed reflection metadata warning. Like we built an API without trimming being a feature that we were designing for, and that's what we have. We're now fixing it.
The question I was asking was specifically about source generators, but in the general sense, not just system text JSON, but all the source generators we're going to build. Are we going to say all the APIs that we're going to want to source gen for, you don't have to change your code in order to opt into source gen?
No, I think we can decouple these two things. I think it's okay to say if you want to get the benefits of source generation, you may have to do something to your code. Right? At the very minimum, for example, you have to put an attribute on something that says, use the source generator, right? But I think the question is now, like, if we're basically saying, like, okay, this is not linker friendly, right? Are we okay with saying we want to push everybody to make your stuff as linker friendly as possible, and that's going to be noisy? Or are we saying, well, we just ship defaults that may keep more metadata than we want. So if you want your Blazor app to be smaller, you have to turn on some other thing that says, link more aggressively, and now you get warnings for, please use the linker friendly APIs, not the linker unfriendly ones. And that requires more code, right? So it's more about the, what's the default experience and like how much does the user have to do to get the app to work, right? And I think that's kind of the thing where it's kind of what's talking to this review today. So maybe we can table that. But I think Stephen has a valid point here, which is if every single feature does what we do for system text.json, like in .NET 7 or .NET 8, at some point, you get 100 warnings for default code because now everything wants you to change everything. And then it just becomes really hard to get an app to work, right? So the question is, can we make this a bit more dialable where you can say, yep, my Blazor app is too big. Okay, dig more aggressively, and now you have to like do more steps to get the thing smaller.
Yeah. During the generation phase, are you allowed to rewrite existing code?
No.
No.
Okay. So I was gonna say, either an analyzer to help with the case, or if the generator phase could rewrite code, it would be you find a call to JSON serializer.deserialize of t with no options, and the t was something you would put the pre-generate the class for, and then it would just change it to call this code for you. Instead, we can have an analyzer that says, hey, you pre-generated this, but you're calling it through the reflection path. Use your pre-generated one.
What if I don't want to use the source generator, and I want to do the minimal work necessary to suppress the linker warnings in .NET 6? What do I change? What do I write?
There's going to be an MS build property that you could just, or do you mean just the linker warnings for the JSON serializer, or in overall?
Yes.
Like
for JSON serializer.
I think you have to stop using it.
Yeah. Well,
You would have to either make an XML file or dynamic dependency and mark all the places manually that the trimmer might remove.
So I suggest
that's if you want to make it
suppressing doesn't do it, right? Yeah, so suppressing wouldn't work because it would just leak stuff out, right? So the app would build without warnings, but then at runtime it might not work, correct?
I mean, the default published trim will only trim system star assemblies, right? So if you're only serializing classes in your assembly isn't touched by the trimmer by default. So it will just work, but you're still going to get a warning.
And I would have to suppress, unless I want to suppress all linker warnings, which I could do with a global no warn, I would have to pragma suppress every call to the system text JSON APIs that be marked as linker unfriendly, right?
Right.
So yeah, that would be the minimum amount of work then. But it's still potentially a bit of work, depending on how many times you call the serializer.
Yeah, I realize we're getting far from the specific purpose of the review, but
it's
we don't trim
because one of the primary purpose here was
right,
to improve linkability.
We don't trim things other than system libraries, because that seems, if we go back to the scenario of somebody wrote a client library for, I don't know, Google Photos API, and that now you've pulled that in and it doesn't get trimmed. I assume that's a point in time thing because people wouldn't have had the phases to be trimmer or linker friendly.
By default, the assemblies that there's a new assembly metadata attribute called isTrimmable, and any assembly that is trimmable true, which we marked all of them in .NET Runtime as true, any assembly marked with that means I'm going to actually trim members out of classes and members out of this assembly.
Okay, so it's assembly level opt-in, not a if assembly name dot starts with system dot.
Right. Yep.
Okay.
It was that a couple releases.
It used to be. Yeah.
I withdraw my question.
But yeah, now like Azure SDK can say, oh, this assembly is trimmable, and so then it'll get automatically trimmed. I still want to ask the question about like not changing my code in order to get source gen things, because if the source gen can't edit existing code, like the only thing you can do is gen new methods, and so it kind of seems reasonable that you have to call those new methods somehow.
Yeah, I don't think we are proposing that, right? It's more about like, how many lines of code do I have to change to opt into this behavior, right? Which I think is reasonable that you say you want to have source generation somewhere. You at least have to tell us what you want source generated to be in the first place, right? So like, there's always going to be some amount of code you have to write. But I think the question now becomes, how many other things do I have to change in order to make the overall system use it, right? And could we make that a bit smarter by saying, we use some amount of limited reflection to find the thing we generated rather than make you pass it in all the time. And then also give you an option to pass it in to avoid that overhead, right? So it's more about the how many steps kind of thing you have to do, right? But I agree with you that in concept, you can't completely eliminate the need for some amount of user code changes. I think that's probably fair.
The only two options there are somehow use reflection to scan, or somehow have an entry point that adds the things to a global, right? Those are kind of the only two high-level options of.
Yeah. Like it could spit out a module initializer, except I think you're only allowed to have one, that calls some new JSON serializer.register metadata thing to shove things in a default bucket. But then
you can have multiple.
Then we'd have fair enough. Thank you. Then we'd have the an interesting security debate about cache poisoning and the ability to overwrite and all sorts of fun things like that.
Yeah.
I mean, the one thing we said before, which I think I want to reiterate quickly, is that we said we generally don't want to rely on source generation for being able to use a feature at all, right? We very often said like it's an optional thing you can opt into, but we generally want to make sure that when we build new features that don't inherently require source generation to work at all, right? Because we know that we can't support it in all languages. We will by default not necessarily even ship a VB version of those in most cases. So the question becomes, where do we draw the line, right? And so if we say in order to make serialization workable in the linker world at all, you must use source generation, that seems like maybe a bridge too far, right? And I think especially when we say most people only ever serialize user types anyway, which we by default don't trim either way, then it seems like it's maybe a bit over the top to warn everybody and make them rewrite their code, right? So I think it's more about that kind of scenario, right? Where you just want to build a Blazor app, you want to serialize some types. Can I do what I do today, or do we make you jump through more hoops?
Yeah, I mean, I think there is a very fair question in here of if you're getting the serializer being called from ASP.NET, where do you get the benefit of this generation at all? And right now it sort of sounds like you can't. And so there's probably a missing feature here, but we can probably continue to talk about the stuff that's already here and see what that may affect in fixing that gap.
So, sorry, why wouldn't you be able to get the benefits from an ASP.NET app?
Because you don't call serialize. They do. They didn't get your context.
You can change the overload.
Yeah, they can expose like another API to take the pre-generated metadata. And
Yeah.
The problem is,
But they would have to do it, right?
Yeah. So the problem is you write a method, right? Call post user data, or sorry, get user data, right? And so by convention, because it starts with get, they make it a controller action. Your return type is now customer details or something. And so because of that convention, they will serialize those types transparently, right? So the framework deep in the download somewhere called serialize, but they don't have access to the thing you just generated because it's in a different assembly, right? They don't have access to your private or your internal JSON context, right? So how would they do that?
I mean, the ASP.NET team is pretty strong on doing code generation, so I assume they would just emit something directly into your assembly. Assuming that they can actually touch that same DLL, obviously.
Yeah,
and that's
saying if you do source generation all the way down, then you can wire it up. Yeah.
Yeah, and so it could be that they end up generating the controller replacement method that is the serialized version that calls the metadata thing, and everything just works happy. But like, we need to understand what the answer is there.
Sorry, I might have missed something, but I just want to say the expectation, at least with this design here, is that anybody who performs serialization for users calling system text JSON would expose the APIs to take that metadata. At least that's what. So yes, sorry to restate in case I missed something else. As far as the mode for. With the feature to expose the default options and change that, I think that would help with the case of not changing your code, but we're not friendly with Linker in case that's something that we still want to pursue. Just to note after taking that feedback.
Just a clarifying question on that. So I've written my cool library, and my cool library uses JSON serialize and JSON serialize or serialize and deserialize under the covers. My method is generic, and it just calls serialize T and deserialize with T. how do I change my library code? You're saying I expose some register method that also needs to be called, and then I use that to somehow populate a dictionary or something that I pass to my serialize and deserialize methods?
Or you add an API that takes a context.
Yeah. You expose an API that takes either JSON context or a JSON type info, which are the metadata codes.
In other words, this is another viral case where if I use serialize anywhere, I have to change all of my APIs. Even if my APIs aren't serialization related, I still have to change them to accept a system text JSON type.
If you want the benefits for your users.
But if I don't care about source generation at all, I don't have to change anything.
And when you say care about source generation, what specifically do you mean?
I just want to keep using the APIs I'm using.
So yeah, that's fine. That would work. I mean, they'll still work, but they will not be linker friendly. They will not. We'll have to go through the reflection code. Like they don't get the benefits.
So this just comes back to my library will cause linker warnings by default.
That would be the case, yes. And in that case, it's harder to specify like some global defaults for the serializer, because like two people are trying to set that at the same time. So I think that mode will be especially needed for it to be easy to reason about.
And to answer your question, Steve, so if you wanted to be linker friendly, if you don't want it to cause a bunch of warnings to happen, you could still make your library linker friendly in a sense that you would just mark all of the APIs that would trigger a warning yourself when you're building that would use this deserialized methods. You would mark them as requires on reference code yourself and just put a message in there and say, hey, I don't know what the type is. It cannot be statically analyzed by me because I'm a library. I don't know what is the context that you're going to want to build. So you just mark it as requires on reference code. You can still be trimmable friendly. And then your consumers, which would be the end app, then they would have to add the dynamic dependency and then suppress the message. And then everything would still be linker friendly. So you could still make your library be linker friendly, even though you're calling deserialize without exposing a JSON context.
Can I use the attributes to say keep everything on the T?
I think so.
It's not going to help because it's a graph, and the linker.
And we have no recursion support.
Right.
Mm.
Okay.
Yeah.
I just want to throw out as well, and I mentioned this before to most people here, is that whether you want to be linker friendly or not, there is a trade-off. If you want to be linker friendly, okay, you're going to get the 100K. I don't even know what the number is. 100K savings at system text JSON assembly, but now we're generating code in your user assembly, which adds space. So there's some sort of threshold or break-even point. I don't know what that is. Maybe it's 100 POCOs. Maybe it's 500 POCOs. Depends maybe on your POCO and how many properties you have and what kind of code we generate for the fast path. But the decision to do that it's not maybe always in your best interest to actually be linker friendly. I mean, there's cases that if you have 1,000 POCOs, reflection might be better.
I mean, if you're going to AOT your code, it agreed. I 100% agree with what you're saying. Like there's a trade-off. But if you're going to AOT your code, and so you can't use reflection emit anymore in that platform, right? Say like iOS, where they just don't allow to generate code at runtime. But yeah, you're going to be bigger, but now you're not going to pay the 100x penalty or whatever it is.
Right. Exactly. Yeah. No, that's a good point. I mean, and that's something that we didn't discuss yet. Is the fallback if you don't have ref emit support in your platform, is to use the super slow reflection invoke, which maybe makes you 2 to 3 times slower, something along those lines. And on iOS, with this approach that Naomi is going over, you get a 2-3x improvement today with these changes, where there is no way to do that without source gen. So it's just another thing to consider.
So we've beat this horse pretty good. I don't know we have an outcome, but I have a different question. Naomi, could you go back to myclass.g.cs for a sec?
Yeah.
So you were talking about, I guess I have a question around versioning. So I ship my assembly that contains this. What happens in the future if JSON Serializer adds another thing that it would normally want to store in the JSON context? Obviously, this doesn't have it.
Yeah.
How does that work?
So would expose a new method that can accept the new features, and depending on what they are, if old new code, if we receive metadata that calls this property at that point in time, but the metadata is not still, because still continue to support it. Otherwise, we have the option to throw stuff like an exception saying not supported, this metadata is expired. But the answer to the question of new features would have a new method that takes the metadata we require to be able to populate the metadata for the new features. So it's these properties are somewhat versioned, and then with if you call an old one, depending on whether or not it's safe to accept your metadata, we'll throw in an exception saying that you should recompile your application or generate new code.
So basically, the closure of the user assembly knows about all of the types that it serializes, whether that's in the user assembly or in some assembly that the user assembly depends on, right? Which basically means they all become in the same version bubble as the user assembly. So if the dependency versions more frequently, that means you're basically screwed because those changes are only reflected when the user assembly is rebuilt.
Which also suggests that I should never publish a NuGet assembly that contains JSON source generated code.
Yeah, you don't want to include still metadata because you can't control whether or not. I mean, we will throw an exception in that case. So I guess the user will
even for my own types, even if in the NuGet I'm using JSON Serializer with my own types from that same assembly, it's possible that JSON Serializer in the future might require an additional piece of metadata that mine didn't provide, and that might throw.
That might throw, and I
don't think we'd ever do that.
That can't be true.
It's capable of serializing right now. We would know how to build the thing that represents the way the world looked today as an internal detail.
Okay, great.
I mean, it's public. It's public API, right?
Right.
This create property is going to be public API. Somebody wouldn't have to use the source generator. They could just use this new public API that we're going to review.
I think that makes sense. I just want to make sure that's not what I thought I heard, so I'm clarifying.
Oh.
No, I was saying, I'm not sure if there's an extreme case where we would want to throw, but generally we'll still be able to call the method, and then we'll use the metadata that was provided at the time. That should all still work. I'm just thinking in the case of, say, breaking change or something, edge case like that.
Yeah, you're basically not allowed to make those, so.
Yeah, so I think to just home in, basically the JSON serializer the source generator is effectively an app level thing. You should not do it at the library level.
Well, I mean, that's not really true. If you're a library, there's no reason you can't use it as an internal detail. What actually seems wrong about this, and I hadn't thought of when talking with Leomi previously, is to go back to an example where there's, what did I say before, Google Photos? A Google Photos client library. If you have a normal application, so not full AOT, and you've registered that you want to do source-generated serialization of something that involves one of those types, if you happen to be running with a newer version of the library that had new properties or whatever, the serializer is going to throw them away because when you generated the property, they didn't, or when you ran the source generator, they didn't exist. So the fact that it's building the entire type graph into the final assembly means it's not resilient to library updates in a positive sense. It would, and then it would do weird things if the things got removed, of course. But and that seems a little weird, though, without rewriting the entire universe to be in terms of interfaces or calling patterns. I don't know what we would do.
So one quick note on that is for the deserialized case, we do have a concept of overflow, our missing properties, so you can enable that on a per POCO basis. which will round trip. It won't help you with the raw serialized case, however.
Yeah.
I mean, if you, like, the idea is take your photo case. If I was referencing your class, and I was like, all right, I'm gonna write to JSON writer, hand code JSON writer code, right? And I know about the 10 properties that you have on your photo class, write 10 times, publish, ship, right? And now you go and add a new 11th property to you're the photo author and I'm the app author consuming it. You add a new property to your library. I don't have that property in my 10 write calls, so it gets dropped. It's just like that, right? It's just, we are codifying it with SourceGen.
Yeah, it's a behavioral difference that was not obvious, or it is an application relationship behavioral difference between calling the reflection serializer and using the pre-generated code. I agree, it's the same as handwriting the code if you wrote it in yours. If the model, without really suggesting we completely invert the model on its head at this right now, if it generated a, from JSON or to JSON method on the type itself when you were running this generator, then now that library, if it was running the generator, it would have updated its own method and it would know how to do the work.
I think that is the reason why the library author should accept the user's metadata, because that way, like, if the user's app changes, they get to see that. So rather than having like caching or pre-generating things on behalf of users, you should have the users pass them to you. That way.
Well, that's actually backwards, because the application knows what the metadata looked like 3 versions ago. The library knows what it looks like today. You're downgrading by accepting the data from the user.
Oh, in the reverse case.
Yeah, I mean, like, I think the question becomes, like, how do we communicate what's happening to users, right? So one option we have is we could say, if you're actually in the library and you enable source generation, and we detect that the closure depends on types that are not coming from your library but from somebody else's library, we could give a diagnostic and say, hey, keep in mind that we bake in the shape of this thing now. So if this thing has a later version in the app, we won't know about it, right? And then you can make an educated decision whether you're okay with that version in constraint or you're not. But I think, like, people will make that mistake probably at some point and be surprised by that.
Yeah,
so now to Steve's earlier point, if you're doing AOT, your choice is get the linker warning that you're calling the reflection thing, or the source generator warning that you're depending on types that you didn't write.
Yeah, I mean, like, that's why, I mean, we need to be mindful of signal to noise ratio for sure. But I think the question becomes, once you, like, I think people will have this mental model that the source generator has 100% fidelity. They just have to jump through some hoops to turn it on, right? And so the question is now, after they turn it on, like, what are the cases when you can observe behavior differences, right? And how can we make sure people are aware of them, right? And that seems like one easy to make pitfall here.
We do have the option to issue that diagnostic if we detect that you are generating metadata for types you don't own, and then can suppress it if you think it's fine, but at least you would know.
Sort of, yeah. I think that, I mean, we can probably, like, scope things out like string and ints, because we know that those are basically fixed, right? But, like, things that are like, some other, users, type basically that you end up sucking in, that one might be an issue that exposes more data in the future. Which I think, I mean, we know from NuGet graphs, it's very, very common to upgrade dependencies. Like it's very rare that the entire closure of the graph has no upgrades, right? So that it will be a common issue people run into.
Yeah, and while it's probably not expected with current .NET application models that you would end up with a random library from the future without having rebuilt your application, it is possible once you end up with the one library referenced another library which is referenced by the application, because now it's everybody needs to always go rerun whatever, or we're basically moving into a shared source world at that point as far as serialization is concerned, because everyone needs to recompile after everyone else to see if they got all the data correctly.
Well, I mean, you can also just say, like, if we only do it at the application level, then you know what the finite, like what the effective set is, right? The problem is we do it on a per assembly level, so
Right,
at
and
that point we don't know.
yeah, again, so that I'm sort of just talking through and looking at that's the model that we're reviewing right now, which is things get built in at the assembly that's going to call serialize. It gets a picture of what the universe looks like. It is not resilient to change, and this is more a problem if it's a library referencing some other library that is then referenced by the application who's not necessarily even aware that JSON is going on, because it's an implementation detail of these two libraries interacting.
Right.
Disguisement wasn't a thing before, right? Like XML serializer, data contract serializer, even like binary formatter, right? Like the type really drove the serialization in those worlds, right? Like you mark this attribute, you put an attribute on this property saying whether it's serializable or not, etc. Where here we're saying like somebody who is external to the type is driving the serialization. I think that's what is causing this change, right?
I mean, sort of, but I think like even in the binary case, like people very often serialize other people's types, right? And so especially in the XML world, like there is no marker, right? So people will just generally like opt in random people's types, right? So in that sense, it's not different here.
But if you want to control it though, if you want to say I want this property and not that property in the serialization, you need to change that type.
Yeah. I mean, like that, but that's what I'm saying. Like if the basically all serialization works like this, that somebody decides who the root type is, and then from there the closure follows, right? And some people explicitly designed the type of serialization, and others didn't, right? So like you always get some amount of randomness because of that. I think the problem here is that the party that decides how the serialization happens versions at a different rate than the type itself, right? And that is kind of the difference between runtime reflection and static generation, right? That's really the only main thing.
Yeah. Technically, you could intercept the default XML serializer by pre-generating an XML serialization assembly for whatever type you were wanting to do, and you can rewrite what its serialization would have done. But that's like no one ever would have talked about doing this because it's nonsense. I mean, I'm sure it has been done because people like attacking serialization code, but
I mean, just to throw it out there, right? A different design would be all the libraries mark the types that they want to serialize, right? And then at the application level, you just collect all of those, and then you only generate one JSON context at the application level, right? And then just find a way to inject that.
Right. Again, the weirdness on that one is the calling application may not be aware that JSON is happening at all. Like you're now forcing a library's implementation detail into the application to host the context.
That's what I'm saying. You find out a way how to inject it, right? Like if the mechanism requires the user to pass it in, that might be complicated because the user doesn't actually write the call side.
Yeah.
And the point is that at the application layer, you know the effective versions of everything, right?
Right. One thought that I had bounced off of Laomi last week was, either we go the WCF interface for factories approach, or we say, hey, we can get rid of the factory types because we're allowed to say an interface has a static member now, but that this all switched to things where everything was being a static interface driven, but that still has the problem of it leaks into your model. In Steve's generic method case, he has to change a constraint to say that he wants and I can serialize myself with JSON serializer, or he'll still get the linker warning. And so, yeah, I don't know that we have, like, I think it's well known that I dislike serializers, and this is just really exposing more of the problems with them existing. I do like the code gen, though.
Publish time source gen.
Yeah.
Publish time source gen.
But anyway, we can keep talking about theoretical alternate designs, or we can try and make progress on what's in front of us.
Okay. So this is the model for POCO. This is a model for an array or collection, strings, lists, dictionaries will look similar to this. Basically, pass the generated metadata for the element type. For dictionaries, we're going to get the one for the key type as well. So it's pretty straightforward. Either you need the custom converter or you don't. And for integer, is the primitive converter case. This is a little stale. We retrieved this from like from a static property to get like a singleton instance of int32 converter.
The Git runtime provided custom converter,
Yeah.
like that. That's an instance method on the base class.
Yeah. So
and that
just,
that can't ever change.
so well, all this is doing is just checking if there's a custom converter and the options that someone has added. So when you say that cannot change, what?
Because you're caching it. You're caching the decision in that generator.
Oh yeah. So at this point, it's locked. Like that's why one of the reasons why we locked the options when you instantiate the context, so we can rely on the fact that nothing has changed at this point.
You can't add converters. You can't do one deserialization and then add converters and do another one on the same.
Already today you cannot do that.
Okay.
Options are mutable after first serialization.
Got it. That answers it.
Cool. Then this is another POCO, my point. So here I just wanted to show what the generated serialization fast path look like, because we just have an int and two integers. It doesn't yet contain the code for honoring some of the options. But in the case where you say, today we have, I'm going to propose a list of options that we will honor during this method, things like ignore, null, and simple cases like that. But yeah, so we can consider like an option for you to tell us at design time what options to ignore, like so that we can have like the fastest code possible if you're not going to use like any customization.
Thanks for adding this.
Yeah, for sure. And then we pass that to so it composes.
I think I missed the thing. So like, don't we have options that control casing? So how does that work when the JSON server option says use camel casing, for example?
So camel case, if you tell us, like we can check at runtime if you used our default camel case implementation. So then we'll compute the value once and cache it. Like we can update this code to be able to like compute it once, cache it, and then do it again.
I mean, presumably for the cases where it impacts the property name, that's just part of the generator, right? Like it would be generating lowercase x versus uppercase x here as part of the string that was spit out.
Yeah, I'm just thinking if you didn't tell us that upfront, because we don't know what the option is. Like we can have a design time thing to say, hey, I'm going to use camel case, and that will make it easy. That will make the implementation easier. But for now, the assumption is we're going to read that from the options the very first time.
Yeah, and if you do have a custom options where you could have specified a different policy, line 83, the first argument could be, underscore x property name question mark equals new JSON encoded string of transform according to the option name transformation.
Right.
Because yes, I took a note for implementation notes on this that you're going to encode the string every time and it should use JSON encoded string, and save that to a field so it doesn't need to do the work every time.
Yeah, definitely.
But,
I assume we don't support or find breaking naming converters, whatever they're called, that change what they output each time they're called, right? Like they need to be deterministic, same input, same output.
Sorry, what was that?
I'm assuming it would be illegal for me to, or erroneous for me to write a naming provider that is not deterministic, right?
But I'm not sure how we.
That you just returned calls plus toString.
Yeah.
It's cached, so if you randomly, day of the week start adding stuff to it, just the first time you get called for that particular property on a particular POCO would only get called once.
Cool. Yep, we use the first one we see.
Yeah, so then we can cache all that similarly as part of the generated code in one way, shape, or form.
That's
question. Because I missed everything.
I could pass in different options. I could pass in a different options instance each time I call this, right?
You shouldn't. I mean, you can't technically. You can't. Well, how to?
I don't know. Like if you accept an options, why can I not pass in the different options each time? I mean, that's the whole point of accepting it, right?
So maybe we shouldn't expose it then. But the only reason we're exposing it is for you to do the fastest thing, not to do the wrong thing. The serializer will only pass this once. And we'll always pass the same instance, do the correct thing. So assuming that users should do that.
If I say serialize point with Pascal casing options, and then serialize point with camel casing options.
Those would have been different JSON context instances because you had different serializer options values.
Yeah, actually, the context is locked to one particular option. So yeah.
Question: where is this func used?
This func is used within the serializer. You pass it along with the metadata for the type. So the serializer knows to call this. Optionally, I'm proposing that we expose it so that users can call it like I've shown here. And that does this gives the best performance you can imagine, because I mean, for throughput scenarios that is, but for startup it's like the same performance as just passing it to the serializer.
But this does have the problem that Eric is talking about.
Right. The fact that the JSON context.default already was wrapping in options means the API definitely shouldn't have taken it.
I kind of think.
Yeah, I think there's a way we can.
Design time decision.
Yeah.
Is my I assume I would put these options onto JSON serializable. I want camel casing and I want blah on this thing.
Right. Exactly. And then it would be if anything needed to be persisted, it would be part of the JSON context dot whatever, which would be built into something this object might reference if it couldn't have been hard coded into the generated code.
Yeah, I think for all, I guess we'll look over them, but I think for all the options that we have, I think they can easily be expressed as like constants that you can tell us as design time. In that case, we won't take our options instance because you've told us what you want to do up front.
Yeah, I guess that's my general question. I don't understand this, because today some of the utilization options are only on the JSON serializable, so the JSON serialization options, like the casing, for example. Like, how can I aesthetically express the casing? Like, the only thing you have is an instance of this type, right? So how can you aesthetically generate code for that?
Yeah, if we have like an enum, like say, use like built-in camel case, then we know what the implementation should be. But if it's something else, then we cannot support that except for doing something like this.
Well, it could be a type that was referenced, type of my cool naming converter, and then the generator could use that, could instantiate it and use it, right?
I don't think we can invoke code, like we can read the type metadata. I mean, but we cannot actually. I see. Yeah, invoke.
Yeah, Eric St. John's design guidelines said the generator shouldn't be trying to evaluate the code because.
No, but the code generator could instantiate an instance of it into the JSON context default my cool thing, and then that would just be used like following.
Oh yeah. I mean, but that would be the same as the line, like the method that was shown. If it changed from having options as a parameter, if it just read underscore options or whatever, because it's part of the JSON context class.
Right. But my point is, like, we can special case ones we know about. So if it's type of camel case provider, then we can hard code something because we know what it does. If it's type of Steve's naming provider, then we can generate something different that use the instantiated instance at runtime.
Yeah. Okay. Yeah.
Is that generating code for all known things, or is that based on a selection that you made at design time?
It would have to be based on something you specified. So wait, just backtracking a little bit. So is it recommendation that we have cases where we will not take an options and only use things that you specified at design time, whereas we also provide another overload that
on line 30 right now, you have two options. You have the visible one that you've passed null, and then you have the implicit one because you're in JSON context.default. So you're in a JSON context instance. You already gave JSON context a set of options. That's the set of options that matters. You shouldn't have two sets of options because if they're in conflict, we have no idea what to do.
Yes. Yeah, for sure. So that would change. I'm just wondering if there's more to the feedback and that.
Yeah, well, there's still the other side, right? So like the problem is that even if the JSON context is tied to a JSON serializer options, you have to statically decide what code to generate, right? And basically we have two options. We can either say we have if statements for everything that can be configured, like we have like all 4 or 5 different casing providers that we emit code for, or we're saying no, you have a way somehow with an assembly level attribute or whatever to say, here are the options I want to actually use. I actually want to use camel case. I actually want to use Pascal case.
Yeah.
And then the generator only has to emit code for those, and for everything else either throws or, you know, do a runtime fallback, right?
Yeah, I don't know that we'd be able to do that because the place that the options got specified and the place that the generator is, like, one of the constructors took an options. So you can't know when you get in this method what options you would have been given. It could generate 2 versions of the method, one for the default options, where we know what the default transformation is, / use the JSON name or whatever the name of that attribute is, for generating this is the name I will use, and then the other would use the I will make a field to hold the JSON encoded string of the name that the options said that I needed to use once I got here.
Right.
But I don't think we can actually do any magic of asserting what types we have because we can't tie any particular call with any particular execution because we had to jump through an engine in the middle.
Okay, so the model today I have, so we keep track of the internal options instance, and then these are the options I'm proposing that we can honor. And these are the ones where we will fall back to the serializer, meaning we'll let the serializer do it. And in this mode, from this set of supported things, I don't have this as part of the proposal, but we can, so I was going to say we can consider like something like this telling us which ones to dial back and which ones not to honor. It seems like there's an alternative model we're talking about where people are telling us what to honor instead, rather than. Well, this is the list. I guess it doesn't matter. This is the list I'm saying like it's feasible for us to honor for now, and then you can tell us which ones here you want. So opt in or opt out, I guess is the question.
But you would have to at least, because right now your code that you showed on the screen, it doesn't check the options for what's the naming policy.
No,
so you just assume Pascal case, right?
Yeah, I mean just as a prototype.
Yeah.
You wrote that over the weekend, right, Leomi?
Yeah.
Yeah.
You know, to be fair, that did come very recently. You know, the ability to shortcut and use that func. And it does have some caveats, right? If you call that func, you're not going to get some of the services the serializer provides, like exception handling. You're going to get the raw reader exceptions or raw writer exceptions or whatever. So you have to kind of know what you're doing, I think, in that particular case anyway. But yeah, we need to fix the options parameter.
I mean, the exception is just an implementation detail of the serializer where it calls it. It can wrap it in the appropriate try catches.
Yeah, I mean, we can generate whatever code we want inside the serialize method, but it would be redundant because when you're calling the serializer, the new methods, because it has a try catch.
Yeah, we don't want to generate like 2 versions.
Right, I'm just like it could still always be a JSON serialization exception wrapping something else. Like you basically control everything of even if you're making new methods, the top level methods could do, if we wanted, do some stuff, catch the JSON reader exception and wrap them as a JSON serialization exception.
Right.
But
I think the point here is that when you're calling that func, you're calling the raw generated code, which has no try catch, right?
But it was private. You can't, as the current thing, you can't call it. Only the callback from the serializer is going to call it.
Well, they expose example.
I'm exposing, yeah. I was showing where you can call it.
But I think that, I mean, we can probably also discuss whether you want to expose these so-called, fast paths anyways, because, I mean, one thing we should be careful for is that if the behavior differs drastically, if it's just catching exceptions, maybe that's okay. But if, the serialized fronts, for example, don't support certain combinations of options or something, and then the other one would, that I think might be a recipe for disaster, because then people will not be able to, determine whether they can safely call them or not. So like if you want to have these as fast alternatives, then we should at least be very crisp about what the behavior is and make sure that they don't differ in like drastic ways, like naming or converter support or something else, right?
The only thing I wanted to say that might help inform decision is that like you do get, so this is what passing that generated context will give you today, relative to what you get with the serializer today. But this is what you could get if you call it yourself. And these are throughput numbers. So like I guess my proposal here is that people will care about this enough to like this is the only reason why you would do this, and do the right thing too.
I mean, I have a really fast implementation that computes pi. It just returns 4, but it's really fast, right? So, I mean, correctness is more important than perf, right? So the question is, like, if we can get this to the point where it's quote unquote correct, I think it's fine. But if it's like, well, we don't support half the options, so, your mileage might vary, then that seems like a bug farm, right? Because then people will use it because we tell them it's faster, but then oopsie daisy, you applied a converter somewhere and then suddenly we dropped it on the floor or something, right?
Well, it needs to be that you can use it, but it may not always give you the perf benefits. If we can't make
exactly right,
if we can't make it that, like, it needs to be, ideally this is pay for play and always correct.
Right. Yes. And I think the always correct is an important design constraint. We didn't talk about it. I mean, when you run the code generator, you don't expect it to randomly fail at runtime because you use some options. So, we're trying to prevent that. We're trying to have a normalized model. And
but
yes.
I would expect that method wouldn't, like, it's a code generator, right? That method simply wouldn't be generated as public if it couldn't be supported. You wouldn't be able to call it, for example, if your options didn't enable it.
I don't know. Yeah, we wouldn't be able to tell.
If it's specified on the attribute, like you specify all the options is relevant on the attribute that generates everything, and then the methods are generated based on that. So
you are explicitly telling us, and then that way it is your fault if you do the wrong thing.
Yeah, if you specify an option we can't support, then the method doesn't exist.
Yeah.
Okay, yeah, exactly. Okay.
Well, I mean, the problem is because right now the context takes the JSON serializer options value, and there are things in that value that mean that you shouldn't call the easy method. That's the complication. But as long as the thing gets generated in such a way that it can know the answer of should I be using, or am I allowed to have used this, and maybe it has to cache it on the first call, then it's would still work.
Right. You basically have two options. Either you specify everything to the description, which I believe we have in the JSON serializer attribute. So we make the JSON serializer attribute as fully complete as possible, such that it contains all the options that are relevant, and it knows at compile time whether it can support something or not, and it only generates the things that it can support. And then if you try and write the code that uses it and it's not supported, it fails to compile. Option number 2 is you have to pass something at runtime, you still generate something at compile time, and the thing that you call checks to see whether the thing that you passed in can be supported by what was generated. If it can, and hopefully that is a fast check, you fall through to the fast case, and if it's not, then you fall through to the slow case, and so it's always correct, but it's pay for play. And then there's the other option of, well, we assume everyone's going to test everything fully, and and we throw an exception if you use the thing and it's not supported, and that one's not great.
In the prototype, the serializer already does not call the method if the options are not compatible. I thought
that's fine. That's fine when it's private, but if it's public, the method itself has to do that check.
Right, but we can't determine whether to make it private or public at runtime. So are you just saying we should?
Well, I'm saying there's two routes to pursue. One is if you expose the options on the JSON serializer attribute such that the code is generated based purely on those options and you don't have the ability to override those options at runtime, then you can call that method directly if you passed in compatible options or not. The other approach is that method is either only private, in which case the serializer decides itself whether to use it, or that method is always public, in which case that method itself has to do that check.
Yeah, just the public
Oh, I
method
see.
would do the
The
same.
public will check. Yeah,
Can I
do
do
the
this?
Same check. I
Yeah.
see.
And then the hybrid approach would be that you generate the using only the attributes on the type / attribute or values passed in the go pre-generate this code attribute as static methods. So there is never an option that got referenced. And then if you called the static one, that's obviously the in the absence of any options.
Right.
Okay. So what should be the behavior when the options cannot be honored? Like in this case,
Call the
like throw an
serializer.
exception. Yeah, but the serializer would need to ask the. Well,
I mean, my preference.
we don't want to do that check twice, right?
Right. It would be that. Well, I mean, you'd have it. So it's if you have the public member, and you gave it an option, and you're built on an options that doesn't support calling the fast path, then it would just call the serializer, and the serializer would be given the private version, not the public version. So it's
And
like
then we can also pass it the context. Okay, got it.
Right.
Yeah.
Right. My preference, I think it's what Jeremy just said. My preference is we basically generate two things. One that's private and used by the serializer if it can, and one that's only generated and is public and it's static and it doesn't accept options and it's purely based on what you specified in your attribute.
I think I'm going to need to see that written down.
So I create JSON serializer attribute that says I want to serialize a foo bar and I want to use camel casing. And that's all specified in the attribute. Two things end up getting generated. The private method that you're already generating today, and that the serializer only calls if the supplied options are compatible. Mm-hmm. And a public static method that is serialized foobar that doesn't take any options and is hard-coded to use camel casing.
I see.
Except for when there was a JSON name attribute on the property. Or
sure.
Yeah, but like it would do a fixed set of things that was determined by static analysis of the code.
And if static analysis deemed that we couldn't generate that method, it wouldn't be generated, and code would fail to compile if it tried to use it.
Yeah.
Okay. Okay. The only thing I would say there's the JSON serializer options are global, not like per type. So I think it will have to not be on JSON serializer attribute, but some other attribute that tells us.
No, this is, I believe Steve's suggestion is the attribute that says, please go run the source generator for this type. We add some options to, like, and give me the fast method and use camel casing. And
yeah, but is the and use camel casing part, we don't specify that by type today. Like that would be
a change for the source generator.
Why do it for one type and not like when would you want to do it just for one type and not others?
When you are wrapping a type that uses, or when one part of your type comes from a library that used Pascal case in their JSON, and you're calling or you're wrapping it with another, and you don't want to go slap attributes everywhere. Like
I think Jeremy is saying that this feature does not exist today.
That exactly. So
feature scope unnecessarily. Maybe this is a bad example, but I'm essentially any options that can be turned into design time, you would expose them to that serializer attributes. Right. That exists today.
And that attribute's type based, so that moves them all to type by type options.
Well, we can add a new attribute. I just don't want to. I think it's a bad idea to add a new feature only supported. Like any feature should be built from serializer to source gen, not the other way around. I would say.
But that's the problem is the serializer works on options. And the statement here is if you want the fastpath code to be public, it cannot be based on options. So you need to replace all of the options for this new method that only the generator is building. So it's now a generator feature, not a serializer feature. That's the context that, at least in my head, that Steve and I just invented on the fly.
Well, would that scenario not be enabled if you apply it for all the types and not just one type? Is there like a scenario that comes to mind where you just want to apply it for one type?
Again, you're assuming that every type that is in the closure of this type uses the same model, which is not necessarily true. Granted, if we say that the local JSON name property wins, or JSON property name wins, then maybe it's already been solved because the intermediate thing had to deal with being called with a set of options that it was incompatible with. But
let me turn around and ask a different question, and I don't know the answer. We support constructing a JSON serializer options, configuring things on it, and passing that in. Does a given app always only create one of those and always configure the options always the same way and pass that same options to every serialized call?
No, not necessarily. But
okay, so then how is this?
No, but in that way, like the options are applied to every type that you pass, not just to one type.
To every type with the same root.
Every type, with the same root to the serializer from the root down.
Right, and if you had different options for two different root level types, then that would be the case where you would now need it as a type level experience in the JSON in the source generator configuration.
Are there cases where the same type is serialized two different ways, such that we would need two different generated? Like, would I ever end up in a situation where I need two different JSON serializer attributes for the same type with different options?
I can imagine where you need to do two different options for the same type. Like, say you're sending some response to the two different APIs that need different casing, for example, is where you use two different options.
Yeah, so we need to come up with. We would need to basically allow the attribute to take the name that we wanted it to generate. It can't just be derived from the type name.
Yeah, I mean, I already took that as an implementation, or as a point to come to later, because if you had the same type from two different namespaces, we're going to generate them as a collision right now.
Right.
Not as a collision. Like the first one we see, we use one name, and then the second one we use a fully assembly qualified name. But
right, but the notion of what you see as first is not necessarily deterministic and guaranteed across versions. So.
What if we could make it deterministic? I just worry that we have very long names. So rather than like points, you have namespace.
It can call it point. My comment was going to be that the attribute should have an optional. You can tell me the name that this property should be generated as.
Yeah, that's what I was thinking as well.
We have JSON property name for that. So, and we do honor that.
No, I mean for the name of the property in the JSON context, so that you can say. My class generate the property name as potato.
Yeah, that's
like that solves and the collision would be you generate it that fails to compile and somebody has to go specify somewhere. Oh, I have two things called my class. This one's called potato and this one's called lemon.
Okay, so what's the recommended behavior in that case? Do we just keep using one name and then fail entirely if there's a collision and then require?
Well, I would say don't track whether or not you've had a collision. That's the compiler's job. It'll see that you've declared the same property name twice. And compile fails. You can maybe be a little friendlier and actually track the collision and give the suggestion that they specify the generated property name optional attribute parameter or optional attribute property. But yeah.
I mean, if it's acceptable to rely on the compiler for that, I'd like to have less code in the generator.
So there's a lot of interesting implementation detail discussion. Should we table that as offline discussion and move on with the rest of the slides?
I was about to say the same thing. We've got 15 minutes left and we've successfully derailed your review.
Okay, so...
I have a question before we move on. More derailing. Do you have an example of how we would change HTTP client to use this new API?
Yes, so we'll just go to the API review then.
Yeah, we have 15 minutes to get through all this.
So everywhere takes in this new JSON type info, JSON value info thing.
Yeah, you missed the conversation earlier about this being viral.
Yeah, okay. So I think one interesting thing is that in ASP.NET Core, the user has to basically set up options globally that then get sent to ASP.NET Core via DI, and we call serialize, and we don't want to be the ones having to look up the type info at the call site. So how does that work in those situations where you aren't passing the context directly to the call site because you don't own the call site? The call site is owned by something else. How does that flow?
One possible answer, just thinking of how things work, is that the ASP.NET DI, right now it takes a serializer options. That the whole thing with this is that basically becomes the dead path and you shouldn't be using it anymore.
Right.
And it can take a JSON serializer context, which is the parent of all the stuff, which includes the options, and then the DI uses that. That has the lookup of given this type, where's the pre-generated metadata. So
Got it.
it's still reflection based in that it does a switch on which type was I given to which table,
exactly.
but that would solve the DI problem.
Okay, so scroll up. That type itself just has a JSON serializer op info and
JSON serializer options was a constructor parameter to it. Yeah.
I see, and get type info. Got it. Okay, got it.
Yeah, I think DI is solved, but it's like when we invented span. There's now a new primitive.
Yeah, that is interesting. Okay.
Okay. Okay. So running through these, we have the JSON serializer attributes. Can be dynamic is useful for when we have polymorphic serialization, and it just allows the linker not to trim out the type, because nowhere else in the object graph references it directly. So if you have like an object array, there's no way to track the metadata for like a string and integer property. So this allows us to do that.
Question: is this internal? If so, does it matter?
Oh yeah. So it's public. This is a copy paste error. So today there's this ongoing discussion around where we should, like, whether we should ship this within system text JSON DLL or we should generate it as part of the user assembly. I am going to circle back here and not discuss it within the context of API, because there are like other reasons, other things to consider. But I guess the idea here is like we either ship this in system text JSON or we generate it in user assembly internally under this namespace.
We do intend for the user to write code that says assembly : JSON serializable. It's just a question of whether we admit it into their assembly or we ship it ourselves.
Yeah.
Seems like we probably need to make it public so that the generator had something to latch onto.
Yeah,
otherwise it has to spit out the attribute to then rerun itself to find out that it needed to use its attribute.
Roslyn has provided a feature that makes this easy, where we can like pre-generate it before we start compiling the user's assembly. So it will be present.
How would the user convey their intent if they want to use the source generator? I thought this was the attribute was the mechanism that they would let us know.
that doesn't change.
I think the user would type assembly : space and JSON serializable would pop up in their IntelliSense because the generator already spit it out.
Yeah.
But that means it would appear in every assembly from now on, even, or depending on where this generator lives. If it's a default reference scope, then every assembly in the future will define this even if they don't do JSON.
Correct.
Which seems weird. Probably not the model we want to do.
Why don't we want to put this in system text JSON?
My understanding of it is that there are some scenarios where we might not be able to provide the generator, as far as like
the generator is an independent parameter. So if you don't, the recommendation from the Roslyn team was it makes more sense to have the generator provide its triggering mechanism so that you don't, you're always in the user is not given the entry point into the generator unless the generator is also present.
And does the generator have the ability to say in the final build JSON serializable attribute isn't being used, so I'm not going to spit it out?
I don't believe so.
Do you have to make an explicit
That's
gesture to reference the generator, or will it be part of a default project?
So right now, the goal for these generators, which we're defining, we're the first. I mean, the reason why it's coming to this meeting is because we're trying to say it's part of the default experience. So, yeah, I hear your feedback, Jeremy, around, we don't want to add this to every assembly. That's definitely I would say that characteristic is higher priority than the torn state characteristic, where you reference the attribute but don't have the generator present. This is a bit of an ongoing discussion with with the Roslyn folks. So I don't think we have a great best practice here yet. I think the existing best practice has these rough edges. So
yeah, it
It'd
makes
be really nice. I mean, there's already some like precedent in the compiler. Right? The compiler will spit out attributes if they're needed and not. So it'd be great if the source generator infrastructure could enable that as well.
Or if it can't do the like weird backward, already need to have generated this attribute analysis. It makes sense to do spitting of the attribute as an internal if you have to make an explicit gesture to reference a generator. But if it's being referenced by default, is when it feels weird to me that it's gonna spit out an attribute. So,
on the flip side, if the linker's on by default, it'll go away if you're not using it.
Yeah, and I mean, if it's literally everything built as .NET 6 and later, then that's the same as we have the the what version did you build against attributes or however the metadata is encoded. It's just it's just weird of when IL DASM my thing. Why does it say I have a JSON serializable attribute?
I fully agree with you. I'm also being facetious because I think even if we have the linker on by default, it's only on default for system.star, not for the user's assembly, so it wouldn't be trimmed.
Yeah, fair enough.
We looked at conditional attribute here, and it doesn't help because it will trim out it will suppress the application of the attribute, but not the attribute itself. Sorry, go ahead, David.
Question. So we aren't putting the context in source generation namespace, right? Just the attribute. That's like a typo.
We are putting everything in, like all
Why?
of the metadata stuff, because we do not. So from the sample here, like users do not have to reference that namespace, just pass the context directly. I don't expect much usages where you actually try to assign it or like.
Well, but it was a parameter in the
It's an argument to serialize, isn't it?
The HTTP context or the the way that ASP.NET was going to fix their DI problem was by changing to that type, but it's under a sub namespace and marked as browser visible never.
For this one in particular, it's fine if we say it's a top level type that users might interact with. Maybe move it up to a higher namespace. But for some of the rest of these, we would definitely want to keep them hidden. Well,
why?
At least my proposal is.
Why?
Okay, so. So a lot of this is exposing serializer internals, and we don't want to we don't want to get to a point where we are tired because of exposed functionality or because a lot of people are using it that we are essentially locked in. So the purpose of the approach of making all of these things that it's browsable never is so that people don't interact with it much. The only reason why we're making them public in the first place is because we need it to be present in the user's assembly. So we're trying to make it as concise and terse as possible.
But that's never going to change. That strategy is never going to change. That we can't break any of this. We can never change behavior. We can never delete one of these things or rename them. Because people are going to source gen their stuff and then ship that assembly, and then if .NET 7 we change something and now it's broke. So whether somebody's going to use it or not, it's not going to change our strategy for how we version this stuff.
Yeah.
Yeah, I mean, I do agree, but I mean, if we don't want people to use it and the only reason why we're exposing it, then what's the harm in making things as for the top level stuff where you might interact with it, but for things like JSON property info itself, or the delegates we're generating, or the internal metadata classes that we need to retrieve, do we need to be friendly and let people use that? We don't have first class features around how they should be used, so it's just implementation detail. So I'm hoping that we maybe say some of these types are maybe the first three here, we move them to a friendly namespace, but the rest of this stuff I think can be tucked away.
So I don't know if you talked about versioning, but Eric, you mentioned that in .NET 7 we cannot break it. When in .NET 7 we have updates to a source generator that will rewrite different code, why would we not be allowed to break it?
Because you can't you can't ship an assembly that targets .NET 6 in NuGet, and now somebody's trying to use that assembly in .NET 7.
Right.
You can't break it. This is public API.
Yes.
This is public API going into the BCL, just like any other public API.
Right.
So in the future,
I mean, you can break it if you want it. People to hate you, but
Yeah, I mean, we can break
anything. We shouldn't do that. We shouldn't break it. I have one more thing. Could we make scroll up to the top? Could we make the get type info generic as well, or could we have a generic overload of that?
Why?
Fast lookup.
I'm sorry?
For faster lookup. If the internal code gets the generic type kind of flown all the way through virally, we can actually just call get type info of T directly and short circuit without having to do. We can do a faster lookup with the generic type than we can with the type info.
So rather than type info, you want type info of T.
No, I want both.
I mean, I'm saying, okay. Well, yeah, we should do that because we have to.
I mean, but if get type info that takes the type object is virtual and the T one is not, then all it's going to do is call the other one, and you got the benefit of, strong typing with the angle brackets, but that's about all it would give you.
It will also be virtual.
Do super efficient stuff.
Yeah, we know how to find it. I would say, we know how to find the generic T1. So this is being overridden by the generated JSON context.
Yeah.
And the generator would know how to fetch.
And today it has a giant switch, right? Like if type is this, return that. If type is that, return that. And it's like a huge switch statement, right?
Actually, yeah, it's actually the generic one we're returning. We just casting it to this. So
but it is possible to implement a type lookup with generics that is much faster than doing that giant if switch.
I mean, the problem would be they'd have to both be virtual. I guess the fact that we're saying that this is generated means generate them the same. But generally you wouldn't want two overloads of the same thing to both be virtual because see also stream.
I get it, but yeah, I do think you want a generic version just because it can be much more efficient than this version could ever be.
It could also return the JSON type info of T, but
yeah, exactly, yeah.
Note that this method though is already on a slow path. Normally it's not called because you're passing in the type info directly.
But that only works if you control if the caller is going to call serialize directly and pass in the information.
Yes.
When you're giving it, like in ASP.NET Core, you return types to the system, and the system has the entire context for all types, and it has to kind of call serialize today. And all I'm saying is that if there was ever a point where we had a generic call site, we could call someone could call the get type info that's generic versus the one that is type of, and the implementation could do a better lookup than what I assume this one does today, which might be a dictionary or a bunch of ifs in a giant
I think the prototype was a waterfall if.
Yeah.
But yeah.
Yeah, exactly. Yeah.
It was. I guess I'll check offline with you on how to make it faster with generics, but
I'll show you. It's pretty cool.
Yeah. Okay. So yeah.
Quick question about the generic thing. Is the idea that with a struct you get if the generic parameter is a struct, you get a custom version of the get type info method that's removes the dead code for all the other types? Or is there something else going on there?
No. I don't think there's a different technique you can use that isn't the struct to eliminate the other code pattern. Because for the most part, I don't think T would be a struct. It's some type defined by user. But you can use, instead of a dictionary or a bunch of ifs, you can use generics to generate a key as lookup into an array. So you don't have to do crazy indirection. I'll paste it in the chat so you can look.
Okay.
So
did you want to continue?
Yeah, I mean, we're now technically at time and basically haven't looked at any of the API. So I don't know that it makes sense to start really looking at the API. I'm offering that as a suggestion.
If we're going to reschedule, let's do this quickly, not wait 2 weeks and then come back and be like, what did we all talk about?
Yeah, I'm planning this for preview 4, so it'd be nice to do as much as like to not have to wait.
Isn't that like tomorrow?
So next week.
Yeah, 10 days.
Yeah. From an API review perspective, that's like tomorrow.
Yeah, so how about like we do Thursday, then another round of this, and then at least do an hour?
Yeah, I just wanted to ask, like what to prepare for. Like, are we just looking at APIs at this point, or?
Yeah, we should not do any more of that upfront stuff that I derailed us on.
Okay. So
No, I think we captured most of the notes there, and I think if you want to change anything there, that's going to be past preview 4, right? So like we will not have time to do that in the next 10 days, I guess. But we should at least capture it in the notes, and then I think for preview 4, how about we just spend an hour because we don't have many APIs anyway on Thursday.
Okay.
As the first item, and see how far we get with that.
Yeah, and while we said no breaking changes, that is no breaking changes once we hit an RTM. If we break something between preview 4 and preview 5, that's fine.
Yeah, that's the whole point of previews.
Yeah. Okay. Thank you.
All right. Then I see you on Thursday.
All right. Thanks a lot.
All right. See everybody later.
Put the thing in the chat.